Yeah. So when they say simplify the radical, you're basically looking for squared numbers inside your radical. Okay. So what squared number is a factor of 12?
Four.
Yeah, right. So 4 is a factor, so it's 3. So what you basically do, the simple idea is that you can separate radicals anytime you want, and then just square root the one of the actual squared factor. Square root of 4, what's that going to be?
Two.
Two.
When they ask you to simplify a radical, that's what you're doing. You're looking at whatever's in here. Doesn't have to be a number, as long as it's a square, either variable or a number, then you can separate it. So the rule that I'm using is this. So if you multiply two things, you can always separate them. You cannot separate addition. You can only separate products. Okay.
How would that work if you used for 6 and 2?
6 and 2 would not work.
Oh, okay. So it has. Okay, I see what you're
Yeah,
saying.
you want to choose a number that's square. So we chose 4 on purpose. Because if you did 6 and 2, you'd have to redo it. So basically, that work would be pointless. You'd have like 6 and 2 right here, and then you break it up into a bunch of 2s, and then the 2 squared. And you know what? I did more work. I should have chosen the squared number or variable. Oh, hold on. I got some messages on the text. Second. This one has a question about the ISLO. Yeah, I need to do it. I want you to do it this weekend. It's due on Tuesday, but just knock it out this weekend. It is required by the whole school, and I'm going to give you extra credit. But if you don't do it, I'm going to take points away. So please do it because they're making us do it. So if I can't motivate you with free points, then I will try to motivate you by taking points away. I guess whatever works. Please do it. All the instructions. Make sure you type the email properly. It should have all the details. Okay. Let's do the next one here. Next question. All right, so what's the squared number that goes into 28? You know what, let's do a different one. Let's do number 4. More interesting. This one's the same thing, right? So what goes in a 75 that is square?
The 5.
What's that?
The 5.
Well, it has to be squared. So a number that is square. 5 technically works, but we want a squared factor. Yeah. See how we choose purposely 25. So then we can separate this and square root the 25. Does the idea make sense? What they're doing here? All right, so different topic. Determine the real and imaginary component or parts. So assuming you've already read about complex numbers on the videos and the lecture, so this is a complex number. It has an imaginary component, right? Do we have a real component? In case you did not see the video, please note that A plus BI is a general complex number. The real piece is this piece. This piece is the complex or imaginary. Do we have, you add one more note, where A and B are real numbers. Okay, so this A is the real number, could be like 5. BI is some number times I, which is your imaginary piece. Looking at our question, do we have an A? Like this?
No.
No, right? But we do have a BI, right? Our B is 29, right? Negative 29. So what is the real part?
Would the real parts be that B equals negative 29 and I equals I, and then imaginary would be A?
Yeah, so the real would be, well, technically A and B are real numbers, but the BI together is the imaginary component. So in the homework, they just want you to put the imaginary part is this guy. The real part is 0 because there's no A. On the test, I'd accept the number or this entire 29I is fine. On the homework, they only want this though. Any questions so far? You guys okay? All right, so the next part, recall that square root of -1 is equal to I. So if you see a negative in there, separate the -1. So for example, square root of -121. To separate the -1 and 121. So what is the square root of 121?
11.
Square root -1 is going to be I. So this becomes I times 11, which is usually written this way. We always put the I at the end. So same as the first few examples, just note that if you see a negative, separate that first. And if you see stuff you can separate in here, separate that too. Let me write that better. Oh, well. All right, y'all cool on this first few examples?
Yes.
Let's do another one similar, just for the practice. Again, this is all review, but we're going over it on purpose. That's what the co-rec part is for. So what squared numbers go into 18? Separate the negative first. This becomes I. Y'all agree that this is 9 times 2?
Yes.
Okay. Any questions on 5? You don't have to put the I at the end. But usually we do.
Quick question. What is the class code for, or the Zoom code for this meeting? Where can I find that?
You should just use in Canvas, just click Zoom, it should be right there.
Yeah, but I have one of the other students is not able to log in, and so she just texted me asking what the Zoom code was.
Is she not using the,
She says she can't log in through her normal computer, so she's trying to, I don't know what she's having issues. So she's trying to log in through a different computer or something for today.
so she's not using Canvas, I'm assuming.
I
All right, hold on.
guess.
It's fine.
Okay.
1 second.
It might be that 9537524, the one at the top.
Yeah, tell her to try that one.
Okay.
How many of these? I don't know. See if that works. Oh, I see. Oh, write the answer in this form. That's what it says. So that's not too bad. So if they have a combined fraction like this, they only have to separate it. So I'd say just separate it first. If you have two numbers over a fraction, that's the same as two fractions separated. So it's almost like this. The I component will come out of here, right? So that will be square root of -1 times square root of 9 over 9. Technically, we can reduce this fraction, right? This becomes an I, this becomes a 3. This cancels. Let me get to here, which is the same as this. All right. Any questions on the fraction work, step by step, or the algebra?
No, but can we do one more problem with fractions?
Okay, so this one was good though?
Yeah, I just want to hear it explained one more time. I get the process, but I feel comfortable hearing it one more time.
All right, we'll do another one with different numbers, I guess.
I'm sorry, can you just go back real quick just to see the answer if I could write it down?
Oh yeah, there's no rush here.
Okay, thank you so much. I'm done. I got it, thank you.
Okay. One moment. All right, so the same example. I didn't write the instructions, but same steps. First step, just separate the fractions because that's what they want. reduce this fraction real quick. Separate this radical. We get 5/3 over here. This becomes an I times 6 over 9, right? So first step is separate into two fractions, reduce, and then deal with this negative. This becomes an I, this becomes a 6. Just bringing this down for the ride. Reduce this final piece here, and we're done. This is 2 times 3. I'm going to put the I over here. This is 3 times 3.
I do have a question.
Uh-huh.
I think the part I get confused on is where are you getting the bottom number for the,
Which one? Where at?
like on the very top, if you could go like to this, there you go, like the 9. Oh, okay, you're just distributing it to the other side.
The 9?
Yeah, or is it for both?
Well,
That's
here,
get
let me
confusing.
show you why. If you add two fractions, right? You agree if the denominator is the same, then you can add them, right?
Yes,
So what happens? You add them, but keep the denominator, correct?
yes.
So basically what we're doing is saying, well, I have some things being added on top. Let's go back to this. So I have some stuff being added. Let's just separate them. That's what we're doing.
Okay, got it now, thank you.
Okay. Yeah, just let me know. Then any other questions?
Can you move it up a little?
I had a question. So pretty much -1 always turns into I.
A square root of -1 always becomes I, yes.
Okay, thank you.
That's pretty much it for this section. You have any questions on reducing radicals, dealing with the negatives inside square roots, or separating fractions like this? I'm gonna move on to something else if you don't.
That's the product. That's the because it can't be simplified anymore.
Yeah, there's no factors in common.
Okay. Sorry, I'm just a little behind.
No, you're good. Yeah, you are fine. And this is the time to ask, right? I don't want you to not ask anything. All right, let's move on in the next section. Just emailing me right now. So it starts off by just, can you identify the equation as linear, quadratic, or neither? The equation is 7x plus 8 equal to 0. What do y'all think? Is it linear, quadratic, or neither?
Neither.
So it all depends on the highest power. So the highest power is what? On the variables. And this is a 1, right? It was linear because the degree is 1. If there was a square in here and that was the biggest, you would say quadratic. If you have something weird like a square root or a negative power, then you say neither. Something strange. So that's just the first one. I think they stopped asking after that. Excuse me. So if you saw the videos, whenever you solve a quadratic, you basically have to factor. Your goal is to get the zero factor property. So note, if you have a times b equal to 0, then a is equal to 0, or b is equal to 0, or both. So notice how here they're factored. So if they're factored already, then set each one to 0 and just solve. You don't have to put the parentheses, just solve for x, right? Add 6 on both sides, get to here. Subtract 3 on both sides, get to there. So your two solutions would be this. So you would type in 6 comma -3 into the homework. Any questions on this first one?
I'm sorry, how did we end up with -3?
So you do +6, +6, you get to here, -3, -3.
I see. Okay, thank you.
Mhm. All right, so the goal is to get it to factored form and then do this. So all the questions are factor using any technique we've already talked about. Any questions on number 2? Sorry, just thinking. So you can do trial and error here because there's no number in front of the x squared. So I recommend just go straight up and then figure out what are the numbers. What are the factors of -27 that add up to 6? So very similar to AC, but not quite. So we got -3 times 9, right? 3 times -9. What else? I think that's it. Yeah, just the one, I guess. So these are all the factors that multiply to -27. But when you add them up, you get these numbers. So which one should I use that add up to 6?
-3.
Yeah, so just put -3 and 9. And that's it. That okay? All right. Once it's factored, we have the zero factor property, so you can solve it. Because now we have an equation, so we're actually solving for something. So a times b equal to 0, so that means you can set the first one to 0 and the second part to 0. Solve for x twice. That's it. So plus 3, minus 9, minus 9. Yeah, if the coefficient is not 1, then you have to do AC method. You could do AC method on this one if you wanted to. But I highly recommend you do AC when you have like a 4 in front of this, or like a 7, some number, random number. But if you have no number, in other words, you have a 1, this is the easiest method. I don't recommend this method if it's not a 1. Second. Let's pick a different one. Let's pick one that has a number right there. Do the AC again. Well, before that, I guess. So if you have x squared minus 13 equal to 0, so if you have just two terms, and we're solving, right? If we move the 13 over, add 13 on both sides, you could use the square root property. So whenever you square root both sides, you have to put plus or minus on the number part. So now we have two solutions. So the solution set would be root 13 and negative root 13. Because we get automatic plus or minus, okay? So that's if you decided to square root. You could have done difference of squares, but since this is not a square, it's a little weird. Like you could have said alternate method here. So, well, if I write this as a square minus a square, right? If I square this number, you agree it's the same as 13? So you could do this and then solve, you're gonna end up getting these two. See what I mean? So I think this one's easier, but you technically could do difference of squares. But as you can see, it's kind of weird. A little strange. Are you guys cool on this one?
Yes.
All right. From 6, 7. Let's do another one that you got to square root both sides. Notice how there's a square on this guy? So this one will be very similar, but there'll be an extra step. Let's square both sides. These squares will cancel, just like before, but notice how I have this 7 here. So basically what that means, if I add the 7 over, you get this. So 7 plus or minus 5. Notice how that's two different answers, right? So x is equal to two different things. So in other words, what is 7 plus 5? What is x equal to 7 minus 5?
Can you go back up? You lost me.
Where at? Here? Or here?
From right, nope, right the very beginning, because I'm lost right here where you have your x minus 7 equals plus 5, and then right below that I see where you're eliminating the 7, and then when you have your equal plus 5 plus 7, and then down here you just lost me right there.
So, well, plus or minus means I have two different 5s here.
Up one more step.
Here.
That's where you have me lost right
So
there.
I'm adding 7 on both sides, right? So I'm putting the 7 here, and these are canceling out. So no more 7s there. So I didn't add it to anything. I just did plus 7. So it's there on the right-hand side now, but I need to add it.
Okay.
But but this is technically two different fives. So I didn't add it until here. I still haven't added it actually. Right? So I gotta do 7 plus 5, 7 minus 5, because this is technically two different fives. If you prefer, we could do this. We could say that this x minus 7 equal to 5 and x minus 7 equal to negative 5, because we have two different ones. Right? And then add the sevens. Does that make more sense? You see what I mean?
Okay, I think, okay.
So essentially that's what we were doing earlier. It's just we gotta deal with two fives plus a positive and a negative, because the square root property here, this is what we're doing here. Square root property. Whenever you use it, whenever you square root both sides, you have to tack on plus or minus to the constant part, the right hand side. That's the rule. Well, there's our two answers. So problem 7. Yeah, I don't think I need another page for this. So on this one, they want us to use quadratic formula. Number 8, yeah. Problem 8. The quadratic formula we didn't talk about last time, but we mainly only use it to solve for x, right? So all the factoring techniques are techniques eventually used to solve for x on quadratics, obviously. And then you could use this too, right? So in case you don't remember or didn't see the videos, when you solve a general quadratic, a x squared plus b x plus c, x is equal to negative b squared minus, wait, that's not right. negative b plus or minus the square root of b squared minus 4ac over 2a. I believe I almost forgot it. That's weird. Getting old, I guess. So here's the question. So can you all identify A, B, and C?
I cannot.
All right, so A is the number on the x squared. Do you see any number here?
It's gonna be y squared.
And there's no number in front, right? Like this one has a number. This is just an A. If there's no number, you say 1. What's the number in front of the y?
9.
That's the B. And then the number, the constant, is right there, right? Okay. So this formula will solve any quadratic for you, given that you identify A, B, C. Okay.
So essentially, it doesn't matter what the actual letters are. We're just making them represent a letter. It doesn't matter which letter, and then we just solve regardless of whatever's going on.
Yeah, so the idea is basically, if I solve this for any A, B, C, then I create a formula. That's how that's how this was found. So this is a solution for any A, B, C. So that means now that you, if you were to actually solve it in general, then you can use this for anything. So that's why you can just say, all right, well, there's A, B, C right there. Just plug them in, and we're done. Okay. That's the idea. That's where it came from. I'm not gonna solve this. It takes like 15 minutes, but let's just go ahead and use the formula. Yeah, I'll just write it again.
I'm sorry.
Mhm.
For some reason, the symbol of the square root freaks my brain out. So what does this square, like, what does it represent? Like, does that make sense? Like, if you were to write out that, how would you write it out in basic math so that my brain can be like, oh, this is the same thing. This is just a faster way to write it, maybe?
Well, a square root. Well, do you know what a square root of 4 is?
Two.
Right. Well, what did you do to get to?
I divided itself. Well, I know 2 times 2 is 4. I don't know why it's that. I just know that's what I get to get it. If that makes sense. Maybe if I knew the principle, I would understand it better, I guess.
Yeah.
I'm sorry,
so,
class. You're probably like, we learned this a long time ago.
No. I mean, that's what we're here for. That's what we're going over this again. It's been a while, right? So square roots are the opposite of squares. So it's going to cancel anything that's a square. So if you have a square, it will be gone, right? They cancel each other out. That's what it does. Cancels squares. That's why when we were reducing the radicals at the very beginning of class, we could only use it on the squares, right? So that's what it does. So in here, there's just a bunch of numbers. You're gonna get one number, and then you're gonna square root it. It's probably not gonna be 4, but it's gonna be some nonsense in here. And then you'll find that you'll multiply it, subtract whatever, square root that number. Because we're just doing number stuff. Okay. Does that make sense? All right. So what do? We plugged in the B. Plugged in the B there again. -4, that's just built in. Times A, which is 1, times C, which is -36, over 2A, 2 times 1. Just multiply numbers, add numbers. So 9 squared is 81. -4 times 1 times -36. No, the hell is that? Is that 144? Right. Add 81. All right. So there you go, a bunch of numbers. You guys said you like numbers. There you go. The hell's that?
I was thinking the same thing.
What is the square root of 225? Does that square root evenly?
That was funny. I'm not gonna lie.
Hey,
15? Cool. All right, so -9 plus 15 divided by 2, that's one answer. -9 minus 15 divided by 2 is a different answer. So, because I'm out of space, x equals -9 plus 15 divided by 2, which becomes something, and x equal to -9 minus 15 divided by 2. The hell is that? 24, right? 12, yeah. Three. I ran out of space, so you're gonna get 3 and -12. Right, any questions on any of this
Um,
beautiful
Can you
stuff?
slide it back the opposite direction real quick?
Back up?
Yeah, right there.
I have one question because you lost me way back here. How did you get 144?
-4 times 1 is -4. -4 times -36 is 144.
Okay, I didn't do the times. Okay, never mind. There we go.
These are all times, right?
Okay.
So this becomes a positive. That's what we got here. That 9 squared is just waiting because you got to do parentheses first, exponents, and then products second or third, I guess. Then finally addition.
I'm sorry, don't hate me. I have it all written down. But can you like talk through it again just so I can like,
Yeah, that's no big deal. All is good. So we're using this formula. In order to use it, you got to identify A, B, C. A, B, C, it has to be written in this form though. Otherwise you can't pick off A, B, C. So it has to be the square, the y, and the constant in a row, all in order, and then equal to 0. A, the coefficient of the quadratic, 1. 9 is the coefficient of the y. -36 is your constant, so plug these three into here. We do that, and we get this. Once you have this, you're just crunching the numbers and simplifying, and then get to here. If you have any questions on the algebra part, of the number part, I guess.
so you don't worry about the square root until after you get down to the 225. That's when you break down the square root, correct? The other one you're just doing.
Right, you
math.
can't square root this entire thing in your head. You could do that on your calculator, but you're gonna get a decimal most of the time. And if they usually want exact answers. So you want to simplify and then see if you get something that you can reduce. If you get lucky like we did, this turns into a whole number and we're good. Right?
Right. And can you move the paper back up to the top? I'm sorry, I missed something.
Yeah, that's all good.
Thank you. Thank you.
Any other questions?
I don't want to say I got it, but I understand it a little bit better now that I did that one.
I mean, the idea is not that bad, right? You're just plugging in numbers into the formula. Simplifying requires PEMDAS, so if you're a little rusty on that, then this may feel difficult. But in essence, we're finding ABC and plugging them in, we get an answer. Most of the time you get 2 answers. That's what we're doing. Our 2 answers are here.
And that's because you're going to do the outcome for the plus and the outcome for the minus. Is that correct?
Yeah, the plus or minus basically guarantees, well, not guarantees, is what gives you 2 answers, but you don't always get 2. Most of the time you do.
Thank you.
Just remember, it has to be equal to 0. So if it's not, move it around. Set it to 0. Man, that's pretty much it for this section. All right, let's look at the syllabus. Where the heck are we? So we finished the material for this week. It's great, okay. But we still have plenty of time, so what are y'all struggling with? Do you need any more time on anything? Are you behind on stuff? Are you stuck on any homework questions? We could do some now.
I needed some
I
extra.
know for oh God. Sorry.
Very good.
Go ahead, Marisela.
I know I needed some extensions. My daughter was in the hospital for a minute, but now she's back and feeling way better.
That's good.
But I
Scary.
thank you. I want to text you on a remind today to see which ones exactly I need an extension on, because I can't remember off the top of my head.
Right now, it looks like everything is open and under late submissions, meaning
Okay.
you still do them without,
Okay.
there's no penalty. I don't take points away. The exam closes tomorrow. I added 2 days just in case.
Okay.
Tomorrow night.
I'll get that in.
So
I won't be able to, tomorrow's Wednesday. Okay, now I just gotta think to myself. All right, thank you.
yeah, so everything's still open. Just let me know if something closes, you should be good.
I have a question. Oh, I have a question about the test. I tried finish. I was doing it like late at night, and I exited out of the lockdown thing, and then when I tried to open it again, it wouldn't let me.
Was it the review or the regular test?
The regular test. It said to like when I was about to exit, it said, "Oh, give a reason why," and then I gave a reason, and then I exited out, and then when I tried to do it the next day when it was due yesterday, it wouldn't let me open it back up.
Was it already past the due day at the time?
No, it was still
Uh,
it was like in the early afternoon.
Okay, let me see. You haven't, so you only took it once, or you took it once and then something happened on the second one?
The real test, the regular test?
Yeah.
Yeah, I just did it once. I did like 2 problems, and then when I had exited out, it just said to give them a reason, and then that was it. And then the next day, it wouldn't let me
Okay.
go back.
Well, let me see if I can do real quick.